Good morning. Today we'll do a short run on the test rig. Let's go inside. So this test rig is a gas, liquid, solid volumetric analysis unit with constant mixing and online analysis. Today we're going to run a short run on the test rig to demonstrate its main operating features. So we've flushed the rig with tap water and the pH is around 7.8. The turbidity is showing 1, so it's nice and clear. And because we've topped up with the water from the head tank above us, the system pressure is 0.9 bar gauge. So in this section, Aprav is putting CO2 into the dosing bottle. So he opens the bottle, sets the regulator, and flushes the bottle with CO2 through to drain, so it blows through to drain at the bottom. This puts 2 litres or 4 grams of CO2 into the system. So now we're opening the CO2 bottle onto the system. The pH is 7.69 and the pressure in the system is 0.9 bar. The water is circulated through the CO2 bottle to make sure that the CO2 is flushed through. As you can see, the pressure drops. You can see the pH dropping rapidly. Now 6.2. .6, and the system pressures drop further to minus 0.1. So we have 5.3 on the system and a turbidity of 14 with some of the small bubbles going around. And the conductivity is still 0. So now Aprav is going to add the limestone into the solid addition system. So we have a double drop and bleed, isolation and mixing pot. We extract a little bit of water out of the top and then drop in the limestone into the top. So we refill the valve and make sure that we've washed through all of the solid and that there's no air introduced into the system. So we're now going to add the limestone into the system. As you can see, it quickly goes very white. Or black, because it excludes all of the light, but opaque. So the limestone circulates for a while, reacting with the calcium carbonate to form calcium bicarbonate. So the pH has risen from 5.2 where it started, and the turbidity has gone to 100. Conductivity has already stepped up to 68. So after a few minutes with a turbidity of over 100, it's now starting to drop. The pH has risen to 5.87 and the conductivity to 250. So the turbidity has now dropped to 74, the pH has risen to 5.94 and the conductivity continues to rise to 315. So the turbidity has dropped to 68, the pH is 5.98, conductivity is 350, temperature has risen slightly because of the circulation. So we now add some magnesium hydroxide into the double bottom bleed. Washing in any powder that's stuck to the inside of the valve. So we can see the liquor looks pretty clear, and now we're going to add the magnesium hydroxide, and there it goes. There's some magnesium hydroxide being added into the system, circulated by the pump. So you can see the pH is rising, turbidity is still 73, conductivity is also rising to 800. The pH has now risen to 6.88, still some turbidity in the system, and conductivity continues to rise. Adding another batch of magnesium hydroxide raises the pH up to 7.5. Again, we still have a rise in conductivity. Turbidity is increased slightly to 94 because the magnesium hydroxide is not particularly soluble, but does react in the end. This allows us to take the water pH to 8 or more, which is safe to discharge to the ocean. So the pH has now risen to 9, which allows us to use calcium carbonate and magnesium carbonate and or magnesium hydroxide to control the overall pH in the system for discharge. This allows a large amount of bicarbonate to be loaded up into the system before it's diluted and transferred out to the ocean. The turbidity is still 80, but as we've shown on our continuous flow tests, it's possible to avoid this by using the sand filters within the system. So interestingly, the system pressure has dropped to half a bar below atmospheric, indicating that the CO2 has been scrubbed out of the system by the combination of calcium carbonate, magnesium hydroxide and the bicarbonate within the system. So we're now putting water through the open loop system. Water is taken from the mains at 1 bar and passes through the first reactor and to the bottom, across the bottom, and then up through the second reactor, around the loop, and then up through the third reactor and out through the top. And it then passes across the same analyzers that we previously had. We can add CO2 in through the top of the first reactor, and the first reactor serves as a CO2 contactor, which it does very well. The second reactor is currently full of limestone pebbles, and the third reactor is used for a number of different minerals, so magnesium hydroxide and or carbonate and limestone, to manage the pH coming out of the system. Thank you very much.